Yes, welcome again to Seremba Online School. As usual, my name is Mr. Katerega Fred. I'm going to be taking you through continuation of waves. In the first lesson, we tried to talk about the common terms used in wave motion. And then we are going to continue with what we call the wave equation. As you see on the chalkboard, that consider a wave moving with a speed v. So like speed is given by distance over time. So to find the distance the wave travels, that means you get the number of cycles times the wavelength. Because in brief, we can say that the distance of one complete wave cycle is equal to wave what? Wavelength. Therefore, you get the number of cycles times the wavelength to get the distance traveled by a wave. Where n you know the number of cycles and lambda means wavelength, because this Greek letter is the one we use to denote lambda, which means wavelength. Therefore, where there is distance, if you substitute n lambda out of the time, this means you remember that the frequency is the number of vibrations a wave makes per second. Therefore, where there is n over t, we substitute f. Velocity becomes lambda f. This equation is very, very important. At your level, O level, they will not ask you to derive this equation, but you need to put it into your mind. V is equal to lambda f, the wave equation, or what we call velocity is equal to wavelength times frequency. Now we are going to see some of the examples whereby we can apply this equation. Calculate the frequency of the wave if its velocity and the wavelength are 5 meters per second and 0.5 meters respectively. Solution to that first question. When you look at that first question, it says calculate the frequency of the wave if its velocity. Solution to question 1. They have given us if its velocity is equal to 5 meters per second. They have also given us and the wavelength 0.5 meters respectively. Wavelength, lambda means wavelength, it is 0.5 meters. Now they are asking you, if you're given the velocity 5 meters per second and the wavelength is 0.5 meters, then you are required to find the frequency. You just say from, you write your wave equation, which states that velocity is equal to wavelength times frequency. Are we there? So our velocity is 5, then our wavelength is 0.5, then frequency. For that matter, you can divide by 0.5, divide by 0.5. So 5 divide by 0.5, then that means your frequency becomes 10 hertz. Your frequency becomes 10 what? 10 hertz. That's a good application of the wave equation. Then we can see the next example. Look at example 2. A vibrator with a frequency of 20 hertz. Now we note frequency is 20 hertz. Vibrates for a distance of 25 centimeter in 5 seconds. The distance is 25 centimeters in 5 seconds, so the time is 5 seconds, but the distance it's going to vibrate for, it is 25 centimeters. In physics, we consider the SI unit. So this distance, which is given as 25 centimeters, convert it to SI what? Unit. Our distance, we can call it, maybe I can call it distance. Our distance, we can call it X. Our distance, we can call it X. So it is 25 centimeters. When you convert to meters, everyone knows you just get 25 and divide by 100. Therefore, it will become 0.250 meters. When you're calculating a question in physics, you have to first summarize the information. Then you bring your formula and make the substitutions. Find, now look at the question, find Roman 1, the speed of the wave produced. The speed of the wave produced. That's our Roman 1. How do we get the speed? I told you that speed is equal to distance over time. Speed is equal to distance over time. Because in this case, if we were to get speed using this formula that V is equal to lambda F, that one cannot work out. Even though you are seeing that you will be having the frequency, but you don't have the wavelength. Are we together? So speed in this case is distance over time. What is the distance? 0.25 out of the time, which is 5 seconds. So our speed in that case, if it is V, our speed becomes 0.25 divided by 5. Then your answer will become a 0.05. Speed is in meters per seconds, and a meter should be a small m in that case, meters per second. So that is the speed of the wave. Then Roman 2, wavelength of the wave produced. Now in this case for Roman 2, where they want the wavelength of the wave produced, now you have the frequency and you have the velocity. Now this means you can use the wave equation to get lambda, because wavelength is lambda. So we can say from V is equal to wavelength times frequency. What is the velocity, which is the speed of our wave? 0.05. So we need the wavelength, you leave it as lambda, times what is our frequency? Frequency is 20 Hertz. Times 20. This means in that case you're having a 0.05 is equal to 20 wavelength, lambda. This letter is called lambda. So you divide by 20, you divide by 20. Therefore lambda is equal to, you get your calculator, 0.05 divide by 20. Then the answer becomes 0.0025. But what is the SI unit of wavelength? Wavelength is now distance. It should be in meters. Are we together there? Therefore, we are going to stop there. Then for other more examples we are seeing, we shall talk about them in the next lesson. Keep subscribing to our channel, Seremba Online School. Thank you.